So the crew engaged in quite a bit of maintenance work today, but the focus, of course, for every day for them throughout the week will be on those scientific investigations uh, happening inside and outside of the station. The ISS truly a research platform these days. It's enabling even more investigations every year to be flown, new capabilities. One specifically that's going to be arriving at the station in the next SpaceX Dragon cargo flight, again targeted to take place in September next month, will be called ISS RapidScat. This morning, we're lucky we're going to learn a little bit more about it. I'm joined now by phone the principal investigator, Dr. Ernesto Rodriguez from the Jet Propulsion Laboratory. Dr. Rodriguez, thanks for joining me today. And if you could start me off, just give me an overview of this device. I mean, it's got an interesting name, that's for sure. I mean, what is a scatterometer?
Yeah, a scatterometer is an instrument that measures winds from space. Uh, Typically, you wouldn't think that measuring the winds, which are so ephemeral, would be easy from space. But what we do is we play a trick. We use a radar that sends out microwave energy, and when the wind blows over the water, it makes little waves. And the stronger the winds, the bigger the waves. These waves reflect the radar energy back to the instrument, and by measuring the return power at the instrument, we can actually estimate the wind speed and the direction by measuring from different incidence angles of the wind. And so with this instrument, which covers about 1,800 kilometers at any given time, we can measure the entire Earth from the space station. It will be between 56 degrees north and south within a day. So we'll have a global snapshot of the winds over the Earth every other day.
So definitely not. I mean, at least to me, not the most intuitive way you would think to measure wind from space. But I mean, that's an amazing capability, and this instrument is being flown. It's replacing another instrument that was on a different satellite. So this is something that we've been trying to work for a while. So what's the full story with that?
And NASA has been leading the measurement of winds from space for a long time. And during the decade between 2000 to 2009, we had an instrument called QuickScat that measured the winds. And in fact, RapidScat is the son of QuickScat in the sense that we've used many of its parts in order to really bring online something very quickly. QuickScat collected data over a decade. It provided an invaluable climate data set, but because of aging over a 10-year mission lifetime, it stopped spinning. So one of the ways we build our global vision is to spin the antenna and collect a large swath. So the instrument is still working, but it can no longer spin, and so it can no longer provide a global coverage every other day. So we took the spare parts from QuickScat, assembled them, tested them, and in fairly short order after QuickScat stopped spinning, we were able to put it up in space and help the international constellation of scatterometers, which also right now has a European scatterometer called ASCAT from the EUMETSAT, to give a global picture of the Earth every day.
So, I mean, much like the station, this project also an international effort. Where exactly on the station is RapidScat going to go?
It is mounted outside the Columbus module, and so actually it's a little bit tricky. We had to turn it because we're using an existing instrument that we couldn't really design for the space station. We built some mechanical attachments to attach to the attach points of the Columbus module and point it down to Earth. So I believe you have an image there of how it's mounted on the Columbus module, and also a beam of how it scans, has a pencil beam scatterometer that has a conical scan covering the 1,800 kilometer swath.
Okay, and just to really bring it home, so what are the readings from this instrument going to be used for? I mean, what will we learn by flying RapidScat on the station?
There are many things that we're going to learn. This specific mission has three components. The first one is that because of the lack of the ability of QuickScat to collect winds over a big swath, we have a gap in our global monitoring of winds. And so very importantly, this instrument will come online and will be able to complement other instruments that are there to give us global coverage every day. And this global coverage every day is used by operational agencies such as NOAA in the United States or ECMWF in Europe to provide better forecasts of weather, and also to do disaster management. For instance, where there are hurricanes approaching land, these data can be used by weather forecasters to get much better predictions as to what the intensity and the track of the hurricane might be.
So an instrument and data that will be affecting a lot of people, especially, just personally us here in Houston. So again, Dr. Ernesto Rodriguez from the Jet Propulsion Laboratory talking to us about RapidScat. Thank you so much for joining us today. Good luck with the mission, and can't wait to see it fly.
Thank you so much.